Today we're going to talk about security analytics, and we've had a security analytics program at NI for a couple years now, 2-3 years. It's something that we've gotten to be really good at because we have so few people on the team. In fact, you are looking at the two people who run the security team at National Instruments. So what we found is by doing security analytics, by running analytics on our environment, that we're actually able to do the work of many, many more people. So hopefully by the end of this talk, you guys will have some tips, you'll have some specific things that you guys can run in your environment that'll get you up and running and make your job easier. So who am I? I'm Josh Sokol. I'm a member of the OWASP Foundation Global Board of Directors. I'm the creator of a risk management tool, free and open source, called Simple Risk, and I'm the information security program owner at National Instruments. I also want to mention real quick, if you flip your badge over to the side that doesn't have your name on it, there's a QR code there. There's also some pretty pictures and whatnot. That is the LASCON badge game, and so far the UT ISO group is the only one who has actually competed in and completed the LASCON badge game. So if you guys are interested, it shouldn't take very long. It's something that you can do on your phone, and we have a really cool prize for everybody who completes it. Just saying.
I am Walter.
Push the button.
It is on.
Is it?
Yeah, it's on. Testing.
There you go.
All right. I am Walter, and this is my I forgot to give Josh a bio slide. So he just filled it out for me. As you can see, I work with him at National Instruments. I'm doing security analytics. I've done all of the shirts and the badges for the most recent LASCONs, like the past few years. Thank you. I do enjoy long walks on the beach and candlelit dinners, and they made me remove my tattoos, but I am a former Yakuza assassin.
So the problem here is visibility, right? When we're looking at our environments, there's just this complete lack of visibility into what's going on in our environments. In our case, we've got a global company, 100+ branch offices around the world, and we need to be able to figure out the answers to these questions up here. Can you guys honestly look at this list of questions up here and say, yes, I can answer all those? And my goal here is, at the end of the presentation, you should be able to answer these things when you go into your environment. Now, the solution here is going to be that we have to create an ecosystem of security tools. We have to be able to take all of our tools, break them out of their individual silos, and get them to work together to answer these questions. We need tools that are able to kind of talk to each other, to leverage data from one tool to the next data. We need a platform that enables the analysis of all that data in near real time so that we can see what's going on in our environment. And so what we really need is security analytics. Most of your environments are probably going to look something like this. You're going to have lots of different tools, and that's awesome, but those tools sit within a silo. And because they sit within that silo, one platform doesn't talk to another, doesn't talk to another. But the fact is, data from my firewall can actually be used for my IPS system, or data from my vulnerability management scans can be used to determine whether an attack is valid through my IPS system. So all these things really should be working together, but the fact is, in most environments, they're not. We have things like proprietary protocols, we have platforms that say, give me, give me, give me, but don't give back, and we have a lot of duplication of functionality. So what we're trying to figure out is how we break out of that. I gave a talk a few years back talking a little bit about this stuff called the magic of symbiotic security. And in that talk, what I did is I kind of broke this out in terms of providers. And providers were systems that like to give data, things with open APIs, open databases, the ability to export data out. And then I also talked about consumers. And consumers were able to consume that data. So they looked at events and alerts and SNMP and syslog and things like that. And by kind of classifying tools in terms of these two categories, we got a much better feel for what our environment was capable of. Some of our tools are consumers, some are providers, some are both. One note is that consumers can be greedy. And what I mean by that is that you have a lot of platforms, especially when you're talking SIM or log management, where they say, gimme, 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 but they're not willing to give back. And so we need to try and avoid those kind of platforms. Because those kind of platforms really don't help us if our goal is to create symbiosis in our environment. So we do all these things, and it leads to something that I refer to as symbiotic security. We basically are able to take all of our tools in our environment, we're able to assemble kind of this arsenal of best-of-breed tools, and even smaller tools can have a very large impact in our environment. This guy right here, by the way, is an Egyptian plover bird, and he actually has a very symbiotic relationship with the crocodile. This guy, so the crocodile will go and he'll eat, whatever animal it eats that day, and what ends up happening is that meat gets stuck over, left over in his teeth. And if that meat were to stay in his teeth, it would rot, and his teeth would rot, and it would fall out. So this little bird comes along, he eats that meat off of there, and he removes that. He's basically like the dentist for this guy, but at the same time he gets his food. It's a very symbiotic relationship, and that's what we're trying to accomplish in our environment. So different questions will require different types of data. And so that's kind of what this is looking at, is all the different questions that you would want to have answered in your environment and where that data is probably sitting in your environment. So if the question is, do I trust the source of some traffic in my environment, I may want to look at reputation data. And there's a lot of sources that you could go to for that information. Or if the question is, who do I trust and who trusts me, maybe I have some sort of a hierarchy. Or what can I access? There's probably some sort of authorization data. So all these different questions have different answers, and those answers are usually sitting in those silos somewhere. What we need to figure out is how do we take that data, break it out of those silos, kind of feed it off, and do work on it. Have any of you guys ever heard of flow or NetFlow? Good, that's fantastic. So what we've done is we've used flow data for a lot of this. What we've looked at is the ability of NetFlow data or JFlow or just flow in general. This is a common feature for modern routers and switches. So if you go out, you buy an enterprise grade, Cisco router or something like that, chances are high that that's going to have the ability to do NetFlow. NetFlow is a summary protocol. It basically looks at IP source, IP destination, ports, protocols, volume of traffic, but it's not the data itself. So you will never get from NetFlow what actually happened on the network, but you're going to know where it went, how it went, what ports it went to, things like that. And that's proven to be extremely valuable. Not that the data itself won't be valuable, but when space is a hot commodity and disk space is expensive at times, this actually it's a quick, easy, cheap way to do a lot of get a lot of data out of it. So this provides a lot of data for a reasonable amount of storage, and our data via NetFlow can help make our security decisions far easier. So what I want to do is, throughout the course of this presentation, we're going to talk a lot about what we're using the flow data for, how we're taking data from some of those silos, kind of pulling it in, looking at the data across our whole environment. So I wanted to get started with a really simple example to kind of elaborate on this. So a while back, H.D. Moore wrote a paper. It was called Security Flaws in Universal Plug-and Play. And basically what H.D. said is he scanned the internet and he found over 23 million IPs that were vulnerable to remote code execution through a single UDP packet. And I thought, that's really interesting. I work at a company that does measurement, test, and automation, National Instruments. That sounds like something we would probably have. And I thought, man, we may have exposure to this. We may have some guy over in R&D who asked for a hole through the firewall, going to some system sitting at his desk. And what would be the ramifications if this actually was an exposure point for us? So this particular vulnerability affects SSDP, Simple Service Discovery Protocol, which runs on UDP 1900. So we had a pretty finite set of information. It's UDP, it's port 1900. So my question was, are people actively scanning my network in order to exploit this flaw? Is somebody trying to find this? Are there barbarians at my gate, so to speak? And so the first step in answering this question is to define what it is that we're looking for. And so to do this, what I did is I created a simple query. I said, okay, my source address is going to be something outside my network. So I'm looking for people scanning me for this. My destination is going to be an IP address inside my network. And I want to find anything in that range where the connection uses UDP, which is protocol 17, on port 1900, SSDP. Sounds extremely simple, right? And so what I've done, this is the tool that we use. It's called Linksien. I'm not a salesman for Linksien or anything like that, but this is the tool that we've chosen to do NetFlow analysis and integration with some of our systems. And so this language right here is called PQL. It's pattern query language. It's very simple to get started. Basically, at the top here, we create an instance, and our instance is each of the different pieces that we're trying to query on. So in this case, I've created an instance for a source address where it's not internal. I've created an instance for a destination address where it is internal. And then I've said, give me a network connection where it's UDP, port 1900. Very simple. I think everybody can understand that. Here we define what connects to what. So we say the source connects to the source address, destination connects to the source address. And then we say, when you give me the results, I want to see the source address and the destination address. Very, very simple query. All the queries are like this. So it's really easy to kind of create a pattern that you're looking for and then get results on that. So the results that we end up getting back look something like this. This is a pattern search of our NetFlow data, just NetFlow at this point, over the past 24 hours. And it returned 539 results. And that query took about 1 minute and 38 seconds or so, which isn't too bad. You get up, you go get a cup of coffee, you come back, and here's your data, right? The end results look something like this. There's a tabular view, and then there's the ability to look at the actual graph analysis. And what you see are these kind of cool patterns. It's almost like an art project or something. It's kind of interesting to look at. But you see this kind of hub and spoke model. And what you have is a single system here in the middle with a whole lot of other systems all connecting to that single system. So it's a graphical view of what this connection looks like. It's all the patterns that we found in our environment. So if we were to zoom in on this a little bit, this is what it looks like. So this is a system on our network right here. You can see, it's a little computer screen there. And then each of these guys around here, I removed a bunch of the extraneous data, but each of these guys on the outside are somebody outside of our network trying to connect to this machine via UDP port 1900. These are the guys, these are the barbarians at our gates. These are the guys who are actively trying to exploit us. And it has some nice features where it'll give us flags and whatnot. US would never attack us, right? So that's what we're doing here. And so I'll give you another example here just to kind of nail the point home. So in this case, we're looking for a source address that's on our network. We're looking for a destination address that's external to my network. And we want a destination IP that's listed in the malware domain list. Are you guys familiar with the malware domain list? If not, you probably should be. It's free. You go malwaredomainlist.com. And basically what they have on that site is a list of all the systems that they've recognized as being malware domain, either host or command and control servers. It's a list of IP addresses. It's a list of domains. And you can take that data, and then you can run queries against it. So this is actually a report that we'll run on a daily basis in our environment. And we look at the results on a daily basis because we want to see if there are any systems in our environment that have been compromised and are communicating with these systems on the command and control list. So we look for source address on our network, destination address is external, and then things in the malware domain list. So very simple. Source address is internal, destination is not internal. We bring in another event here, which is the event from it's a malware event, basically. And then we look at the source address, destination address, and then the malware target. And actually, when I'm looking at this, I'm knowing that this query does not actually do this. So we messed up in terms of that slide. But the end result looks something like this. So this is the pattern search for a NetFlow, and this is actually our malware prevention appliance, our FireEye system. Over the past hour, I returned 134 results, 2 minutes and 4 seconds. And it's really interesting because what you see is this is our system in the middle. You see a little bomb here. That means that actually this is not our system. This is the system they're connecting to. This little bomb is associated with that. That's the actual malware target. And then these are all the systems on our network that are connecting to that guy, right? So that's a surefire sign that there may be an issue there. Closer inspection, some detail removed. Again, in this case, here's the one system there that everybody's talking to. Here's all the systems on our network that are talking to that. And then that's the malware event, the guy that's associated with that. All right. So let's go and talk about some useful security analytics. You want to talk about the darknet one? No, you good? All right. So this is another report that we actually run on a daily basis. What we've done is we've created a list. So we have a very large, IP range internally. And what I did is I went through and I said, okay, out of this huge range, we're obviously not using every single IP address out there. So let's look at the ranges within that range, the sub-ranges, that we're not using, that we don't have systems on. And then let's look for all the other systems in our environment that are talking to those IP ranges. And it doesn't matter if there's a system there or not, we're just trying to see if somebody's trying to talk to it. So what we do is we create that list of unused IP addresses. We look for those internal systems that are making the most connections to the IP. And the way that we do this is we say our source is going to be internal, our destination is internal as well, and the IP address is in this list that I've created of all of our darknet IP space. And then we run that query, we export, and then we get the results back, and it'll give us a count of the number of times a system on our network has attempted to connect to a system that's in that darknet list. Now this is extremely useful where you have a system that's been compromised, and now all of a sudden it's doing scanning activity. So you will see this system, it doesn't know which IPs have stuff and which IPs don't, and inevitably they are going to hit an IP address in this darknet space. So we can very easily detect when that happens, and we can find those machines. So anything that connects to one of these systems in the darknet is either misconfigured and probably should be addressed, or it's compromised. Very, very simple. Another way to do this is via DNS requests. So depending on how your environment is set up, this can be really useful, or it can be really, really troublesome. What we're trying to do here is we're trying to look for systems in our environment that aren't connecting to our DNS servers. So hopefully most enterprises' environment will have an internal DNS server. All of your internal systems will connect to that guy. Maybe it's a domain controller or something like that. And then that one system makes all the outbound requests on behalf of your organization. That's typically how it works. And so what we're looking for here is any system that's actually making calls to a different DNS server, not our DNS server, so an external query. And so the way that we do this is we look for a source that's internal, we look for a destination that's not, and then we look for anything using UDP 53. That should be a DNS query, right? And so by doing this, we're able to run that query. We look for anything for the destination IP address and the number of times, and now we're able to get that list of systems that are making those external DNS requests. And for us, maybe it's going to Google and maybe we don't care. Maybe it's going to some other weird DNS server and we do care. So this is a good way to detect certain types of malware, but it does require your environment to have kind of locked down DNS on your desktop level. By the way, if anybody has questions, feel free to raise your hand, interrupt us, and happy to answer.
So Josh, did you guys find stuff internally that was compromised?
Oh yeah. We find stuff, I would say, at least on a weekly basis, we'll find systems with these analytics, absolutely. In fact, I would argue that these kind of analytics, they work better than antivirus. They work probably better than even our FireEye system. So, do you have a comment?
So what's the query product that you have, the P, what's it called, equal or something?
This is, PQL, pattern query language is what the language is called. We'll take that offline.
Okay.
Yeah, I don't want to be a salesman. I don't sell the product. They don't pay me to pitch it. So for the point of this presentation, we're talking generalities. Right? Okay, so we talked about this one. DNS data exfiltration. So this one has proven to be valuable in certain cases and kind of a time suck in other cases. But here what we're doing is we're trying to find all the data that's leaving the company. And I'm creating here a top 25 list of the most data that's being sent out. A lot of times you'll find false positives. You'll find, especially in our environment, we have a lot of engineers who will send large ISO images to a customer or things like that. So we do find some false positives with this, but we also find some stuff where there's a whole bunch of data going to some IP address in Russia. What's up with that, right? So in this case, we're looking for a source address that's on our network. We're looking for a destination address that's external to our network. So we're making sure that this is being sent outside. And then we just sum up the number of bytes sent, and we get the top 25 that boil up. So the way this works in PQL, we limit 25, that says just show us the top 25 results. Is internal is true for the source address. It's false for the destination address. We have our connections. And then when we run the results, we look for the source, the destination. We actually pull in the country code, the destination port, so we know which ports it's going to, the count, and then the sum. And the count actually ends up being interesting because you can see if there's a lot of little bits of data over a large time, make it up, or if it's just like 50 packets or 100 gigs, right? So that helps out a lot. So we find a lot of stuff with the data exfiltration, especially in a lot of our overseas branch offices where we don't have the same detection mechanisms that we would at our corporate office. Yeah. So then we have network reconnaissance. This report right here. Do you have any design? All right. All right. I told Walter I can keep talking forever, right? But all right, so network reconnaissance. So in this case, we're looking for systems that have been compromised that are scanning our network for stuff. And this could be like a Nmap scan or something like that, Nessus, somebody doing discovery on our network, basically. So in this case, we're looking for a source address that's on our network. We're looking for a destination address that's not on our network. And then we want to get the count of connections any IP makes to any other IP address. And so very simple, we've got all those different pieces here, and then we export sensor IPv4. This simple fan analytic, so what we're doing here is we're basically doing a nested search. It'll run over that, and then it'll do a research of that data to give us the count and the sensor IP. So the sensor IP is actually kind of an interesting data point. What happens is your net flow comes from multiple points on your network. And so depending on where your sensors are, you may see data across multiple NetFlow sensors. So what this guy is telling me right here is which sensor we're finding that data on. And so if we see traffic in multiple sensors, this will actually show up in two separate areas. So this actually ends up being kind of interesting. When we have weird IP addresses that show up on here, things like that, we're actually able to track it down to the exact device that traffic was passing through. All right. So here's one for system analysis. This is outbound connections by protocol. So in this case, we're looking for a source IP that we're going to specify. And so if I have a certain system and I'm thinking, man, maybe that system's compromised, maybe I want to look more into what that thing is actually talking to, this is the great way to do it. So in this case, we look at a source address that we specify, we look for any destination address, and we basically run that over, and the end result is what ports is that guy talking to, and then the sum of the data that guy's talking to. And so we can see this one system, where most of the data is being sent to, which ports, where is it communicating most, and so if we suspect the system being compromised and we run this report and we see a real weird port on there, 31337 with a whole lot of data going out to that, chances are pretty high that system is compromised and we have something to look into here. Yeah, so the way it's set up in our environment is each of these different NetFlow sensors all throughout the world are all forwarding into a single system. And then from that system, we're basically able to redirect it into multiple feeds wherever we want, so we can actually consume it in multiple places. We forward that onto our tool, and then our tool basically stores that NetFlow data in the database and gives us the ability to report on that, as well as taking in other pieces of data and allows us to report on that as well. So,
how far back can you store flow data? Just as far back as you want, or is it just
so
too much space?
the major limitation is going to be disk space. So if you and database size, I guess. So if you have lots of disk space, you can save a lot of data. If you have very little disk space, then not so much. So so we don't use Bro at NI. It's something that we're looking at specifically with the security onion stuff and the components of Bro that integrate with that. We'll probably be doing some of that stuff next year. But this, I think I have some more stuff coming up where I show it in tandem with some of our other tools. So let's push forward on that. Yeah, so a lot of times, we'll kind of filter it. So we're only two guys. We'll try and filter it based on number of connections. And by doing that, we'll see something, it made one request to a malware domain list IP. For me, that's not something that I care about that much. What I'm going to be looking for is like multiple callbacks, command and control servers, things like that. So if I see 100 connections to IPs listed in the malware domain list, now all of a sudden I'm more interested, and I'm going to pay a lot more attention to that. So you kind of have to look at, if it's 1, 2, it's probably a system that talked to something, it didn't get compromised, I'm not going to waste my time trying to track that down. But if I see repetitive, if I see day after day, if I see continual traffic or large volumes of traffic, those are the ones that we're going to try and run to ground. All right, let's keep going, and let's talk about performing incident detection and response with flow data. So what I did is I took an actual situation at NI where we had some alerts, and you'll see kind of what our daily alerts look like with some data filtered out. And I wanted to kind of throw this out there because I want to see what you guys would do in this situation. So in our situation, we saw this. This is that darknet IP address report. I've kind of filtered out the initial part, but this is 75.27, and we saw 641 connections to a darknet IP space. So my first question is, who would see this? How many of you guys would actually see this in your environment? Yeah, that's kind of what I thought. So this is extremely valuable, right? I now have an IP address in my environment that's talking to darknet space. So this guy is either misconfigured at this point or compromised, right? Because normal IPs or normal systems on my network aren't going to talk to blank space. So 641 connections to darknet space. So what about this? That's that same system, 75.27. This is our simple fan report, which basically looks for scanning activity. It's a system that talks to lots of other systems on the network. And now we know it's already talking to 600 plus IPs in darknet space, but now we have 2,866 connections to just any system, right? So first of all, how many of you guys would be able to detect this? We've got a few. Okay, awesome. We've got a few who can detect the scanning. And then secondly, we have a system here that at this point I'm thinking this is compromised, right? This guy, he's doing lots of scanning, he's talking to IPs that he shouldn't be. This guy's probably compromised. But then we take this a step further and we see this guy too. This is a search that we created to look for zero access. And this one does tend to have some false positives because basically all I'm looking for is connections from an internal system to ports, these guys, right, via UDP. And this was just a quick and dirty signature that I rolled out just based on some observations with zero access. And I said, all right, show me any system that's making these kind of connections. So how many of you guys could do this kind of thing? You could say port-based, show me anything talking to that. All right, a few more. Good. So in this case, that same system, we see 68 times was making queries that match this pattern. So for me, I know this system is compromised at this point. Scanning activity, talking IPs that don't even exist, and then zero access search. I'm pretty sure that this guy's compromised. So, all right. So assuming that you could detect this, how many of you guys could actually answer these questions? And I think we know most of the people in this room probably can't answer these questions yet. And so this is why it's so important for us to be doing these level of security analytics. So question one was connecting this IP address. We create a simple pattern, right? We say, let's use a target. We specify this particular IP address. Show me any case where this guy, where anything is connecting to this IP address. And then give me the count of who's talking to it. And so I specify a time range. I want to know when this is doing it. I run the search pattern for that IP address. And then I get back and I see 500,000 things, are talking to the IP address. And there's my results. And so I can see the number of times it talks. I can see the source IP addresses. And I just kind of pulled out a couple things and I said, wow, this is Dewan Communications. I have no idea what Dewan is. A lot of the other stuff was like Amazon, whatnot. Knew they were doing a lot of that kind of stuff. And then Facebook. All right, this guy likes Facebook. Cool. So, question number 2, what is this IP address connecting to? And so in this case, we create a very similar query. In this case, we just swap it and we say IPv4 address is target on the source. Same kind of thing, we look at the destination and the count now. And with this, we run it and we get 846,000 results. And these are our results. So we see a few IPs at the top that it's talking to Amazon Web Services, some weird feral hosting, I don't know about that. Dewan Communications again, this must be some back and forth. Softlayer.com, not sure of. But this one looked interesting. Hosted-by ihc.ru. That's weird. I've never talked to those guys before. So we know who this guy's talking to now. All right. So question 3, do I have any alerts associated with the IP address? So now I want to look at my other systems and kind of pull in data here. So what I did is I said, all right, run me a search for any alerts from my FireEye system, run me a search from my IPS system, and then tell me if you find anything. And in this case, my answer was no. We don't have any alerts from those guys. Cool. And then question 4, is there any significant amount of data loss from that system? Right? Want to know if stuff's going out. So I create that pattern. I look for this specific IP address. I want to see all external connections. I want to see country code, destination port, and then the sum of the bytes sent, and I get something like that. So I can see this particular system, I can see all the destinations, I can see what ports it's talking to, and I can see the sum of the data. So in this case, here's the list, here's everything it's talking to, and how much it's sending. And 18 megs to some random IP address in, what was that, Latvia? I don't know. That doesn't seem good to me. So by using this tool, this kind of framework, by doing analysis of NetFlow, by doing analysis of the devices on our network, kind of pulling it all together, we're able to answer these questions. And these are very important questions as security professionals for us to be asking and being able to be answered. I wanted to make a quick note of the collective intelligence framework. So this is a cyber threat intelligence management system that allows you to combine no malicious threat information from all sorts of different sources that use information for identification, detection, and mitigation. And this is free, open source, and basically you can download this CIF guy and you can collect data from all these different places. You can collect it from public sources, you can collect it from private sources, and then you can use it to push data to other systems. So you can actually create your own collective intelligence framework. You can actually harness data from all these other sources and then use that to do your reporting as well. So quickly, we're running short on time, but I want to talk about some next steps here. So in this case, we can ask ourselves, are there alerts associated with this host on my IPS or other monitoring devices? In this case, we've answered the question. The answer is no. We can also do things like reputation data. So in our tool, we can do queries for WAFSEC. Josh Amishlav-Zatin, very active with mod security, created this service, and it's free, where you can send in query it for an IP address, and it comes back and it tells you where it's located and what latitude and longitude it has, and it'll tell you if there's spam associated with it and things like that. So it gives you some valuable reputation-based data on that. The McAfee threat intelligence data is actually interesting too. Same kind of thing, you send it an IP address and it says, here's the email reputation, here's the web reputation. So for this particular IP address, this stuff is kind of coming up cloudy. To me, this looks like nobody else has really seen this IP address before. I don't know necessarily it's an APT, but yeah, I don't know. And for this particular one, which wasn't the one that we were looking at earlier, this is a false positive in my opinion, because we don't see a lot of reputation stuff there. So what else? For real-time decision making, you can ask questions like, should I accept packets from random IPX? And obviously, this tool is more after the fact, but this is where we'd like to get with this kind of data. We want to be able to take our reputation data and our attack data and our vulnerability data and our asset data and any information about trust boundaries and bubble that up to be able to say, yes, I should accept data from that guy. I trust him. It's from a known source. It's from a source that hasn't attacked me before. Or no, that guy is being shown on my IPS alerts. I see alerts from my FireEye. That system is bad. Don't trust any data from there. That's where we want to go with this. Should I allow some person to download a file? Well, what's the data classification of that file? What's the reputation data, the authentication data, authorization, trust boundaries, things like that. So we need to figure out what are the right questions that we should be asking, where does that data sit, and then how to combine that data into a query that returns meaningful results for us. In terms of taking action, so we can do all sorts of things when we have these results. We could block an IP address with some sort of firewall or IPS system. We get back a list of things that they're doing wrong, send that off to our IPS or our firewall, and just say, let's block them. We could create WAF rules based on attack data, and if we've seen certain types of attacks, we can feed that data back in. We could ban a system from communicating our network. We could require some sort of additional authentication and say, okay, well, you're doing some suspicious stuff on our network, so now let's do multi-factor authentication and require you to enter a PIN off your phone or something. Some might even say attack back. This was the former CEO of HB Gary said the bad guys are so pervasive, according to Hoagland, that some companies are taking matters into their own hands. Victims of attacks are fighting back by hacking the hacker, where the hacker becomes the hackee. Obviously, some legal challenges here. I'm not going to tell you, you should hack other people. I'm just going to tell you that other people are. So to kind of summarize this, a lot of companies, I think, are suffering from the lack of visibility into critical security threats. I think that the lack of hands when we ask those questions kind of sums that up. Security analytics allow us to see and react to those threats. The ideal tools are ones that have both the provider and consumer capabilities because they can kind of intermingle. We want to combine tool data together because that gives us the context that we can use to make informed decisions. And then in our case, at least, network flow data is really the glue that ties all these different events together and helps us to illustrate the attack progression. So that's how we're able to do that. Do we see any future in terms of being able to automate from the point of detection to the point of responding to this? And my answer is yes. I think that we're kind of pushing the limit in terms of what the tool and technology is able to do, but as an industry, that's where we're moving. We want to be able to ask these questions in real time. We want to be able to answer these questions in real time. And we want to be able to act in real time. So absolutely, this is where we need to go as an industry, and if our tools aren't taking us there, then we need to figure out how to get there. So yes and no. We don't have full PCAP through this tool. It does not give us that. In terms of searchability, we are able to pretty much run any search that we want to get to this looks suspicious. The problem that we've had by not having PCAP is moving beyond that. Oftentimes you'll get to a point where you're like, you run all these queries and you're like, damn, that system looks infected, but I want to know what data it's sending. I see data exfiltration. What was the file name? What was the data within that file? And unfortunately, it's very difficult to get to that. So if I had my druthers, I absolutely would like to have the PCAP data as well, which is why we're looking at things like Security Onion to be able to actually capture some of that data in addition to the flow data and things like that. Our goal is to get more and more granular and get this closer and closer to real time, but we are still, in addition to these are kind of supplementary, we're still doing all the kind of standard stuff that you would be doing. So we're looking at antivirus stuff, we're looking at malware detections, we're looking at IPS, firewall logs, all that other stuff that everybody else is doing. This is just stuff that we're doing in addition, and the unfortunate thing is a lot of that other stuff, it's kind of a sieve. So when that stuff kind of lets stuff leak through, this is where we're catching that. NetFlow is very small, it's very simple, it's easy to run searches on, and it's quick. So if you're trying to get quick and dirty, that is a great way to do it. If you're trying to get deep into the weeds, it is not. I think that we all know that antivirus, when it's signature-based, it's easy to route around that. If you listen to the speed debates, you heard my response to that yesterday. Yeah, it's signature-based detection is dead, regardless of what Nickerson tries to tell you in a speed debate. We have to move more towards behavioral analysis in order to get the job done there. So early on, our tool had some bugs in terms of making multiple things work together and whatnot. They've done a much better job of kind of fixing some of those things. Walter and I were actually having that conversation the other day. We want to be able to find stuff where this guy is in the IPS and it's in the FireEye and it's in the darknet and whatever. You bubble that stuff up right away. Yeah, and that's absolutely that's where we're going. Yeah. All right, so I think we're done with time. Thank you guys. If you have questions, we'll stick around.